So in this particular topic, we will be discussing what is the difference between the ideal Brayton cycle as well as the actual Brayton cycle. Now, from all the previous concepts, we never come across the actual cycles, is it? We only studied about the ideal cycles. It might be your Otto cycle, diesel cycle, or any other cycle. We just studied the ideal form of it. That means if the ideal Brayton cycle is from 1 to 2, 2 to 3 and 3 to 4, that is the ideal form of it. What happens if the compressor, which is compressing the gas from 1 to state 2, does not perform up to the mark? I mean to say, it has to compress the gas from state 1 to state 2, but it does not, but instead it turns down to just 2-1. So you all know that all the machines are not so efficient, that means 100% efficient to carry out the processes as stated in the ideal Brayton cycle. Therefore, if the compressor process was intended to happen from 1 to 2, but it will not happen, it will just go in the actual Brayton cycle, it will just go and deviate a little bit to meet at 2 dash. Similarly, for the turbine also, turbine was intended to go from 3 to 4, but because of the inefficiency of the turbine, what happens, it will not reach the state 4 as in case of ideal conditions, but in 10 it will reach to the state 4 dash, which is a actual Brayton cycle. Now, if I want to observe the actual Brayton cycle, it will be what? 1, 2 dash, 3, 4 dash and 1. And the ideal Brayton cycle would be just 1, 2, 3, 4 as normal. Clear? So that is all the description given below. You just take it down this. After that, now here we'll be defining the compressive efficiency as well as the turbine efficiency. Now remember, the compressive efficiency is given by isentropic work, which is the ideal work divided by actual work. Okay, let me give the diagram of this. So if I place it here, yes. So similarly, in the actual Brayton cycle, in the turbine efficiency, it is actual work divided by isentropic work. Keep this in mind very carefully. So remember one thing, you can reciprocate the other. Compressor efficiency is isentropic work divided by actual work, whereas the turbine efficiency is exactly opposite. It is actual work divided by isentropic work. So we will always remember the turbine work and reciprocate for the compressive work. So turbine work is actual work divided by isentropic work. Actual work in the sense what? So it is H3 minus H4 dash. H3 minus H4 dash, here it is. So H3 minus H4 dash is the actual work which is happening, which is not ideal, right? Isentropic is ideal work. So isentropic is H3 minus H4. Getting it? So similarly for the compressive is exactly reverse. Isentropic work divided by actual work. Isentropic work in the sense ideal work. Ideal in the sense just 1 to 2, is it? So H1 minus H2. Always initial minus final when it comes down to the work calculations. Okay. So isentropic work is what? H1 minus H2 for the compression. But the actual thing is 2 dash, right? So actual thing is H1 minus H2 dash. Similarly, you will develop the relations as prescribed here. So just take it down. It will be very much helpful for the previous things. Okay.